kind of kept up with urban, but not out west. In the western US, it was about 1/6 of the growth that was seen in urban areas was seen in rural. And I'm imagining for any of you who are from this rural community, you probably had a chance to notice that directly. And that creates great danger for rural economies. Basically, if we find ourselves in a position where qualified people start to leave the areas that they would like to live in simply because there aren't any jobs, then that basically makes it less possible that the companies that are still in place survive, and certainly less probable that new companies will come in to that community. And that really becomes the beginning of almost an economic death spiral. And in spite of that, there are great advantages that rural has to offer. Land is much more abundant, much less expensive. Power is usually cheaper. Usually water is too, less oversubscribed. The rural broadband disparity has changed significantly. I'll take a little credit for that with the company I started years ago. Workforce is very motivated to see those jobs stay locally because they want to continue to enjoy that wonderful lifestyle that rural makes possible. And candidly, there's a lot of financial advantages to starting businesses and running businesses in rural America. If you take a look at, again, 14% of the population is rural, but 40% of our opportunity zones that have been designated are in rural communities. Community reinvestment favors rural communities, especially if a community reinvestment project area is designated. There's significant numbers of USDA rural development loans and grants available, and I can't overstate how important it is that hub zones, if you're going to be doing business with the federal government, which especially with what we're about to go into is going to be a part of what's going to happen, hub zones creates massive advantages for people who locate in the hub zones, and as near as I can tell, it was almost 60% of hub zones are in rural America. So what is this new opportunity? Well, it's actually simple. Okay, maybe it's not so simple. But actually, in reality, it really is simple. Because what we really have here is the existing grid, and we're integrating new renewable energy generation opportunities. And then we're augmenting those with batteries so that we can basically load balance and optimize. And just those opportunities, whether you're talking solar installation integration, wind, microgrid, all of those things create tremendous potential for businesses that average humans, average individuals can actually launch. Let's talk about power generation, intermittent versus baseload. Baseload is basically coal, nuclear, natural gas, and so forth. But the renewables are intermittent, and what that basically means is when the sun's not shining, the wind's not blowing, we don't have power coming onto the grid. And when it is, we more than likely have more power coming onto the grid than the grid can actually handle, so it's a good idea to actually store it locally so we can trickle it onto the grid when that actually makes sense. For those people who really haven't studied the grid, it's really an intricate, delicate balancing act where literally it cannot take more power coming onto the grid that's being consumed elsewhere across the system. Due to that, we're starting to see a lot of batteries being deployed in one of two different types of flavors. One is called BESS, which is battery electric storage systems, which are on the grid side of that equation. And then BTM is behind the meter, which is essentially premise-based. On that side, for the most part, what you're trying to do is either pull down power when it's less expensive, or make sure that you get to avoid brownouts, or in some cases, sell power back to the utilities, okay? And on the BESS side, really what's happening is the companies that are basically funding solar and wind, they are only going to maximize their ability to turn those investments into something profitable if they can actually store that energy that can't be accepted by the grid when it's not capable of taking that. And the reality is, the charging station situation just kind of saw a huge kind of negative PR bump when two things happened almost in the same couple of weeks. The president of Ford tried to take an electric vehicle Ford across country and said, "Oh crap, we're not ready yet." And then basically Jan Granholm of the DOE tried to do the same thing. It kind of became front page news. And the reality is, when you really take a look at what electric vehicles are capable of doing, they're great for around town, but there is a lot of, not so much range anxiety anymore, now it's charging anxiety, and that creates a tremendous opportunity as well, okay? Now, as far as the grid itself, the grid is about to undergo a massive upgrade, and the numbers range from 1 trillion to 20 trillion. And either way, those are really big numbers. And ultimately what we're looking at is we're looking at a grid that was designed, some parts of it, your typical transformer is actually still using a design that was essentially created 100 years ago. You have a very specific input, a very specific output, and those are about to change in part because of things like dialable silicon carbide transformers. But we have this grid that is, well, here it says 70% of the grid is over 25 years old, and the majority of the grid is still over 50 years old. And in that, essentially, you're going to see all of these things become a part of this massive upgrade. As I mentioned, GE just came out with a silicon carbide dialable transformer that actually means it's much easier to deploy, much easier to maintain spares, all sorts of interesting things happening there. Fortunately for us, we actually started out NexGen Materials focused on how to make very inexpensive silicon carbide powders, so we know that world reasonably well. The BES, BTM space is all very, very battery dependent. We're about to see two-way flow of electricity become a common thing as opposed to a rarity. Again, that's going to be based on a lot of what are called wide bandgap power semiconductors, again based on silicon carbide. A lot of new power lines. I don't know that we're going to be involved in that, but I think what happened just recently in Maui, we're seeing a lot of people, and actually California a couple of years ago, we're seeing a lot of people seeing the wisdom of burying power lines so that they're less likely in rural areas to start fires, okay? And then obviously Internet of Things is going to become very valuable in terms of making sure that we actually have a true command and control system that understands what's happening in the grid in real time. It's kind of interesting when you take a look at the grid shutdown that happened in the northeastern United States. I want to say it was about 10 years ago. There was about a 6-hour delay in terms of a round-robin game of telephone happening where people really didn't understand what was happening. And with 5G, and even with broadband over power line, there's a lot of ability for this stuff to become truly instantaneous in terms of command and control. So, what does this really mean? Well, to start with, it's batteries everywhere. And right now, the vast majority of batteries are made in China, about 76%. And we're doing a really good job of pulling battery cell manufacturing to the United States. We went from about 11 factories coming online to now there's about 72, and that's all good news. And there's all sorts of different types of batteries being made. I think in the BTM space, I'm still betting on lithium ferrous phosphate, and we've got some things that we're going to be looking at doing there. I'm a big fan of redox flow batteries, iron flow, vanadium flow, things of that nature. The EV chargers, they're going to have batteries. They're going to actually be sucking their power down into a battery, which will then go into a charger, not directly. And there's even talk of actually making the EV batteries themselves part of a virtual power plant system. So the good news is batteries are going to be a really big part of this. The bad news is you can't really become less dependent on China for battery manufacturing just because you move battery cell manufacturing to the United States if they still control all of the battery materials. And right now, they control the vast majority of the battery materials. So basically, the battery ecosystem kind of looks like this. You start with pulling the stuff out of the ground. You've got to locate it and secure it and permit it. And permitting is a very big problem, mine it. Then you have a scenario where you need to extract, refine, process, or in some cases synthesize. We'll be synthesizing our graphite. You then build the different types of cells, and there's all sorts of different types of cells and different chemistries that are coming. And then basically, the next step after making the cells, and cell manufacturing is very, very expensive, by the way. If you want to get into the cell manufacturing business, probably going to need to raise around $600 million. And it's the smallest amount that I've heard actually be realistic so far. But then subsequent to that, you actually take those cells and you put them into what's called battery pack assembly, and that's very dependent on how you're going to use the batteries. So people who understand aviation versus people who understand power tools versus people who understand ATVs, all very different, but huge potential in that particular part of the ecosystem. And then down the road, we're going to see more and more importance being paid to recycling. A lot of people ask me about recycling. It is projected, well, right now the vast majority of recycling that does occur is scrap that's coming off of battery material or battery cell production. It is projected that it will reach parity where batteries truly being recycled and scrap will be 50-50, probably 20-30. And the reason is if you just went out and bought a $70,000 Tesla, There's going to be a lot of people who are going to be doing what they can to enhance and extend the life of that battery in the Tesla, because ultimately you have almost a disposable car if you basically have a vehicle that, let's say 4 years from now, is only worth $30,000 and replacing the battery is $20,000. Tremendous amount of economic incentive to keep those batteries going, okay? So, as far as the different places to participate, this is kind of where you can see the compound annual growth rate in all of these areas is growing pretty consistently, which makes sense, okay? We, however, tried to figure out where's the margins, because being in the IT industry, I've already perfected the art of working really hard not to make very much money. I prefer not to do that again. I'm going to be a little wiser as I get older. But really, as I mentioned, battery cell production and mining are very, very high CapEx and OpEx. Refining, processing, the space we're in, and actually battery pack assembly are actually reasonably high margin activities that can actually be taken up by smaller organizations that want to participate in this ecosystem. And as mentioned a number of times here, we can see that the US is not really on the map here just yet. But there's a number of reasons for that. The biggest really has to do with the fact that if you take a look at the reason why the batteries are chosen, when Elon Musk came out with the first EV, he basically had to figure out, where do I go get the batteries that are made in the largest volume? And it basically came down to this. This is the battery that everybody made tons and tons of, because when you take a look at the number of cell phones that are made and the number of tablets that are made and the number of laptops that are made, that battery chemistry was chosen not because that was the best chemistry, it was just the most available and the one that made the most sense, okay? But now, as we start to see all sorts of things happen to really diversify what batteries are going to be used and are specialized on a per application basis, that whole world's going to change quite a bit. But still, when you look at this, it's unfortunate that essentially all of the battery processing got pulled to China. The largest producer of lithium, for example, is actually in South America. I got a biology degree from Johns Hopkins, not a geography degree, but I am 90% certain that South America is closer to North America than it is to China. And as a result of that, what's essentially happened is we've seen all of the materials essentially escape our sphere and then become returned back to the US. This section alone, and I'm not asking you guys to jump in necessarily and compete with NexGen materials, but I will tell you there's a lot of room in this space. There's a lot of room for innovation. There's a lot of room for smart people to get into this space and make some money. So here is where we'll talk real briefly about NexGen materials, kind of our shameless plug. What do? We try to identify materials that we believe are going to be in a demand versus, a supply versus demand shortfall for at least 10 years. We try to find a unique way of sourcing that material. We then add some kind of intellectual property that creates some type of defensive moat around that, and then we build very efficient capital stacks around the joint ventures that we're going to build that will allow us to actually move this stuff into production. And we'll ultimately have multiple JVs in multiple areas all around the country, okay? At that point, we basically go out and we recruit who really cares about this particular thing we're going to be doing in this particular area. It has been our hope and intention, and we still expect that we will be putting a graphite facility in Price on Ridge Road sometime down the road on the Opportunity Zone. And essentially, by virtue of our partnership with the group that hands us off the synthetic graphite, they make very inexpensive, very clean, very high quality diesel. So finding a company like a Flying J that we're speaking to, probably care about inexpensive diesel is a good idea. Finding organizations that have coal and coal finds. The coal finds need to be cleaned up, the coal needs to be monetized. Finding organizations that basically need battery cells, because if you can't put battery cells into your BESS systems because your battery cell manufacturer has no lithium and no graphite, they become interested. So ultimately the joint ventures are about how do we pull people in who care about the output as well as the probability that we'll make money on the investment. Our initial 4 projects essentially are a direct lithium extraction methodology that we started out focusing on how do we separate magnesium from lithium, because there's a very large waste pile in Utah that we think we could do something with. However, we found out that we might have the only method of doing direct lithium extraction at scale that does not use any fresh water, which I'll repeat again in a minute. Our graphite facilities, we'll probably put one hopefully in Price soon, but our first one looks like it's going to be in Memphis, Tennessee. Actually, interestingly, I just spoke to the industry leader last week in Detroit, a company called Novonix. Their graphite's going to be more expensive than ours, and we use CO. It'll actually create far more CO2 than we will. And at the end, they're going to produce about 10,000 tons of graphite, synthetic anode quality graphite per year. The industry needs a few million tons per year. So there's a lot of room in this space for competition. We have an interesting project where we're basically going to attempt to work with the federal government to do a better job of using some abandoned mine waste money. There's about $2 billion of that. A recent funded opportunity that happened in Pennsylvania used abandoned mine waste money to make a 4,400 foot rock crawling trail, so the people who liked rock crawling could drag their rock crawlers out to this trail and crawl across the rocks. And then presumably the economic activity was they would go get a beer and a burger afterwards. I think we have something better planned than that. And then candidly, we actually started this whole thing with silicon carbide, which, you know, it's not there yet, but it's gonna be a big deal as well. Keep listening for it. As far as DLE, what really does happen right now is the evaporative ponds that are 1,000 years, you know, plus. Maybe Pliny actually was paying attention to, you know, evaporative ponds back in the day as well. But evaporative ponds use somewhere between about 2,000 and 3,000 tons of fresh water per ton of lithium produced. The acknowledged industry leader in the DLE space uses about 20 tons of fresh water per ton of lithium produced, although we're hearing anecdotally from industry partners that it's actually not that good, okay? We believe that we're going to use less than 1 ton of water per 5 tons of lithium produced. And whenever I actually have this conversation with the PhD that he sponsored the research for this, he says, no fresh water. So maybe no fresh water, but even if we're just using 1 ton for 5 tons, we're going to be an industry leader. And this has huge impact on the Great Salt Lake. I think a lot of us have been watching what's been happening there. Actually, Leonardo DiCaprio just weighed in today, so finally maybe something will happen because someone important cares. And then, but you know, the sadder part is really what's happening in the Lithium Triangle. You know, these indigenous tribes that, you know, basically were decimated 400 years ago by the Spanish with an extractive mindset of taking all the gold and silver, that China's about to do that in South America for lithium as well. Graphite is a big deal. Graphite is the vast majority of what goes into a battery. It's projected to be somewhere between 28% and 45% of the physical volume of the battery. We'll not only be making that graphite, but we're also going to be working with a local mine, and you'll be seeing Dr. Wheeler talk tomorrow about something happening with a local resource that should make a very specialized nano-sized porous silica that actually enhances the ability of graphite to work with silicon in anodes, which increases energy density and reduces the amount of graphite that we need. Silicon carbide in EVs, basically everywhere you need fast charging, you're going to have silicon carbide. So basically the inverters, where we move to fast charging, the charging stations themselves. But more importantly, any place that we're going to see two-way electrical transport happening in the grid above 700 volts will be silicon carbide. Below 500 volts, it might be gallium nitride. So, in this space, basically there's multiple places for many companies to compete. And I'm joking about coming and competing with us in the material space. There's plenty of room. We're personally avoiding cobalt. We don't really like how cobalt is currently sourced, and then candidly, thermal runaway issues with cobalt when cobalt-based batteries happen is quite painful. But all of these areas create tremendous potential for rural communities to participate in this explosive industry. And candidly, there is more money coming at this than anything I've ever seen. This will give you an idea of what's happening in the venture capital space. It's just exploding in the last 2 years. But more importantly, the Department of Energy went from a $15 billion lending authority to a $413 billion lending authority in the last 2 years. Now, unfortunately, a lot of that is going to Australian and Canadian companies because the DOE has to de-risk this. And basically, right now in the battery material space, you have China, Canada, and Australia. And if you have China, Canada, Australia, and the rule is no China, then basically we now have Canada and Australia. But there's a lot of room for American companies to step into adapt and be innovators. And candidly, we need to step up. It's not like Utah to punch below its weight. If you take a look at where all this activity is happening, it's happening a lot of places, but nowhere near as much in Utah, or even Idaho, or Wyoming, or these other places as it should. So I've actually helped raise money for 2 different battery factories, and I can tell you it's not very easy to raise $500 million. It's much easier to raise the kind of money that is necessary to participate in this space. We have all of the right resources. We're a mining-friendly state, we're a business-friendly state, we're a transportation, we're ideally suited for transportation and so forth. We have an opportunity to really step up here, and we'll take the leadership of companies like UAMI, Governor's Office of Economic Opportunity, working with the national labs, all of that to really make this a reality. But the opportunity is today. And basically, I would ask you to, this is a good way to get a hold of Guy. I thought Lance was going to be here today. We're working with the Energy and Geoscience Institute out of the University of Utah, who's pivoting into battery materials. We are their premier battery materials partner at the point currently. Although we'd like to see more companies come in and work with us in that space. And then we're growing. We're going to be looking for the right partners. We're going to be looking for the right people. We'd welcome the opportunity to talk to all of you. Any questions?
Any questions for